Okay. In the previous, I provide you some solution. Now I will provide you more. Okay. Is okay. Determines okay. The homeworks of the first section is about the block diagram point of view. Okay. How to combine the block diagram or simplify the block diagram in the term of the single input and the single output. Okay. The relation between the output in the term of the input clearly. Okay. In this case, okay, you see that we track step by step. Okay, y3, you know that y will be equal to y3 plus y4 plus y5. Therefore, we try to write y3 in the term of x first. Okay, y3 equal to the transformation of t3. Okay, the block 3. Okay, the input is y2. Therefore, the result from t2 and t1. T3, T2, T1 of the input xn. Okay, we got the first one. Okay, the second one, okay, y4 is the close similarly form of the y3, except that the transform of the process is T4. Okay, the T4 of the T2 and the T1. Okay, therefore, in this case, okay, y equal to y3 plus y4 plus y5. Okay, the transform of y3 is in this form, y4 is in this form, and the y5. y5 will be the transformation of the 3,5 and 3,1. Okay, yeah. Next one is another block diagram is here. Determine the output yn as the function of the input and the system transformation of the following figure. Okay. Y will be in the term of the product of the y3, y4, and the y5. Therefore, you must determine y3, y4, and the y5 in the term of x. The same as the previous, okay? Okay, y3 will be the transform of t3, t2, and the t1 of the xn input, okay? y4 will be the transformation of 3, 4, t2, and t1, t4, t2, and t1, okay? Therefore, the outcome, yt equal to the product between y3, y4, and y5. You know y3, you know y4, and y5. You can express them in the term of x, okay? y5 equal to t5 and t1 and x. t5 of the t1 of input xn. Okay, the last one. The last one is have a little bit feedback control module, okay? Therefore, the way to write them may be a little bit complicated, but we write them step by step. We express y1 first, okay? If you don't know about this signal is, you maybe write them to be y1, y2, y3, y4, or so on, okay? y1 is the product of process t1 and x, okay? Therefore, the outputs y, you can write outputs y in the term of, okay, term of the y4 and x, okay, as with x, and here m is the process of t2 and the summation between xn and xt and y4, okay, and after that we express, okay, y in the term of this, okay. Y, okay, for this case, you convert them y, we can write them in the term of m and y1, okay. You can see that y is adding between y mt and y1 and part the process tt, okay. And after that, you substitute m, okay, you substitute m from the previous equation into here, okay. Now you can see that in this case, this equation will be relate between the input and the output, okay. And in this case, due to it have some feedback part, therefore the output will be depend on the input and itself, depend on the input and itself. The next one determines the output yt as the function of the input of the system again. It have the feedback again. We had two feedback loop, okay. We express y1 in the term of yt first, okay, and x, okay. y1 equal to the difference or the subtraction between x and, okay, y, okay. Therefore, it's xt subtract with 3, 4, yn. And after that, we can write m in the term of input is, okay, and the output, okay. M equal to the difference between here and y1 and y1, you know about that, substitute them in this case, okay? And don't forget about y3 that will be subtracted. In the next step, okay, the output y t equal to the transformation of t2 and m. You know m, you substitute them in this case, okay? You will get the final equation that have only input xt and the outputs yt. Okay. Next one is about the, okay, provide you some solution of the, yeah, some of the system property, okay? Determines whether the system described by yn equal to 3x 3t plus 3 is a memory or not, invertibility or not, causal or not, stable or not, time invariant or not, and linear or not. The first one is the system is a memory because the system outputs yn is a function of the system input at other percent of time xt, okay, and the output is depend only on xt minus t naught or xt plus t naught. It means if the output is in the form of, okay, the time shifting version of the input, the system is memory. In this case, we see that, okay, it have three. Three is for time shifting. If we have time shifting, the system must be memory. The next one, the system is invertible for this case because the distinct system input xt produce the distinct system outputs yt. And the next one, the system is causal or not. In this case, it's non-causal because if it's shifting and it's shift, okay, if the t naught will be equal to negative, okay, the general form of the shifting t minus t naught. Therefore, in this case, it's part 3. Therefore, t naught equal to minus 3, it's negative. Okay, if t naught is negative, it means the system is non-causal. Okay, the system is non-causal because the output depends on the input at the future time. The system is a BIBO stable because the system output is bound for all bound system input as following proof. You will check first, okay, if the input is stable. Okay, it's stable, it means it have the maximum point. The maximum point is maybe equal to m, okay, and the maximum is not infinity. Okay, now checking that if the input is have the maximum point, what about the output is? The output in this case is 3 times of the input is. Therefore, it's a 3 of the maximum or m, 3m. If m is finite, 3m is still finite too. Therefore, we can conclude that the system is a BIBO stable. The next one is determine whether the system is time shift, time invariant or not. We can process checking them by process them first and ship them later, or ship them first and process them later. If the result is equal, it means if it equal, it means the system is time invariant. Okay, you see that in the final step, okay, it's different, right? It's minus t naught, it's minus 3t naught. Okay, it's not equal, it's time varying. Okay, the system is time varying because the system input xt minus t naught, that is the time shifted, does not produce the system outputs yt minus t naught, that is the same time shifting. The next one is if you fix x1, okay, you determine y1. In this case, if you fix x1, y1 equal to 3x1, 3 minus 3. Okay, if you fix x2, y2 equal to 3x2, 3 minus 3. If you fix x1 and x2 at the same time, if you can organize or simplify the equation, that write the term of the input in the term of y1 and y2, okay, you can write here. And you can check that if you fit x1, give you y1. If you fit x2, give you y2. If you fit x1 plus x2, if it equal to y1 plus y2, it means the system is linear. The system is linear. Okay, it's true. Therefore, the system is a linear. The system is a linear because the system satisfies the principle of superposition for the additivity and homogeneity property. Next one, okay, another one example, the exercise is determine whether the system described by yt equal to cos x t minus 1 is a memory or not, invertibility or not, causal or not, stable or not, time invariant or not, and linear or not. The first step is, in this case, the system is memory because, okay, yt depend on xt minus t naught. If it already in the time shifting version, it means the system is memory. Therefore, we can conclude that the system is a memory because the system outputs yt is a function of the system input at either of the present time xt. The output is depend on xt minus t naught or xt plus t naught. It means in the form of the time shifting version. Okay. The next one is the system is non-invertible because the distinct system input xt may produce the same system outputs yt, such as cos minus theta equal to cos theta. Okay, or cos 0. Okay, cos 0 equal to 1, or sorry, cos 90 degree. Okay, cos 90 degree or cos, okay, pi divided by 2 equal to 0. Okay, in some term, you know that the cos is a periodic function. Okay, the value that it generates will be repeat, and in some value of the cos result maybe have the several degree that can meet that requirement. Okay. The system is therefore the system is non-invertible because the distinct system input xt may be produced the same system outputs yt, such as the cos minus theta and cos theta. The next one, the system is causal because the system outputs does not depend on the input at the future time. Okay, in this case, it depends. The system will be causal if the output may be depend on the input in the time shifting version that T naught must positive. Okay, in this case, T naught equal to 1. Okay, next one, the system is a BIBO stable because the system output is bound for all bound system input that you can prove in the following this step. You know that if the input is bound, maybe very high one but finite, less than m. Okay, but you know that the output of cos must be between -1 to 1, right? Therefore, the magnitudes of them will be between 0 and 1. Or maybe conclude that it must less than absolute 1. Okay. The next one is the time invariant. Okay. The time invariant can checking by you process them first. Okay. Send xt to the system, give you cos xt minus 1. Okay. And delay them after that. Delay them after that. You delay every time by t naught. Okay. Or you will delay them first. Okay, you maybe delay them first and process them later. If you delay them, xt is delay version become xt minus t naught and process them. When you process them, give you here. What happened in this case? The result is still equal. If it equal, it means this system is a time invariant. Okay, the system is a time invariant because the system input xt minus t naught, that is the time shifted, produce the system outputs yt minus t naught. That is the same time shifting version. The last one is, okay, the system checking that the system is a linear or not. Okay, if you fit x1, y1 equal to the cos x1. If you fit y2, y2 equal to, oh sorry, if you fit x2 to the system, y2 equal to cos x2. But if you fit x1 plus x2, okay, cos x plus x1 plus x2 or cos a plus b, give you cos plus minus sine. Okay, it don't give you cos a plus cos b directly. No. Okay, therefore, if it's not equal, it means in this case the result will become non-linear because the equation, okay, this thing is not true. X1 plus x2 does not produce y1 plus y2. Okay. The system is non-linear because the system does not satisfy the principle of superposition of the additivity and homogeneity. Okay, the next one, determine whether the system described by this equation is following these 6 properties or not. The first one is a memory because the summation, the integration starts in certain period between t to t plus 1. Therefore, the system is memory because the system output is a function of the system input at other percent of time xt. Therefore, the output is depend on xt minus 3 plus 1. Okay, and In this case, the system is invertible because the distinct system input xt may produce the distinct system output yt. Moreover, we can express xt in the functions of yt as following here. Remember that the integrations, you can revert them, okay, to be the differentiation. Next one, the system is non-causal because the system output depends on the input at the future time. You can see that if it in the time shifting, okay, or in the time, it depends on t plus 1, right? 3 plus 1 is the future. If it in the futures, it means the system is non-causal. Next one, the system is a BIBO stable because the system output is bound at following proof. You can check that, okay? If the input is finite, it's less than m, okay? What about the output is? Okay, if it's finite, you integrate this value, okay? It means you integrate in some certain period, give you n multiplied with 1, and therefore the final result is still m. If it's still m, it means it's stable, okay? It's stable. Next one is for the time invariant. The time invariant, okay, you process the input first and delay them later, or you delay them first and process them later. If the result will be equal, it means the system is time invariant, unless the system is time varying. Okay, the next step we delay them first. Shift every xt by t minus t naught, okay, and integrate them after that. In this case, you can see that the result is equal or not, is equal, okay. If it equal, it means it will become time invariant, okay. You can formulate the equation and substitute them, okay, make every t delay shift by t naught is the same, okay. The system is time invariant because the system input xt minus t naught, that is the time shifted product, produce the system output, okay, y t minus t naught, that is the same time shifting. Okay, I think I provide you a lot of the solution. Now we will go to the next one, okay, the next chapter. Okay. Now, can you see my slide? The next chapter. Hello, can you hear me?
Yes.
Yes.
Okay. Okay, I will bring the water a minute, okay? Drink the water 1 minute, sorry. Okay, I will come back. Okay, now, okay, can you see my slide?
Yes, sir.
Okay, the chapter 3. Okay, now the chapter 3 is a little bit more complicated than the chapter 2. Okay, because it reads you to the special operator, we call them the convolution. This chapter will present the special system. In the system analysis, we know that the system have up to 6 properties that we must concern. The memory, the causal, the stable, time invariant, and so on. Okay, but in this case, if the system is already have 2 properties clearly, it have the linear and it have time invariant. Okay, we call them LTI. Okay, in general, the linear and the time invariant system is very important in engineering designing because almost all system is a linear and a time invariant assumption. Why? Why is math linear? Why is math time invariant? Okay, almost all mathematical for solve the non-linear, you never find in the majority. Okay, if you interested to solve the non-linear problem or non-linear equation, you figure study in the master, especially in the PhD, because the mathematical to solve the non-linear is very, very difficult. Almost all mathematics, I think 95% of all subjects that you study for bachelor degree is linear. It's linear. Okay. If it have another one property, it's a time invariant. Okay. It will help me. Okay. It can facilitate the problem a lot that you can solve it. Okay. This section present the system that have both the time invariant and the linear property. Define the system described by the following block diagram equation here. If it have the input, you have the output. Okay, you know that the output can find from the process of the input. Okay, by the ST system. If the system is time invariant, okay, it means if you're shifting the inputs by T naught, output must be delayed in the same time manner. Okay, we call them that. Okay, the system is a time invariant if the time shifting of the input result in the same time shift of the output is. You see that if you delay the input, output will be in the delay in the same manner. Everything is the same, only shifting. Okay, the next one, if the system is a linear, it means the system satisfies the principle of superposition. Okay, it means if you feed x1, give you y1. If you feed x2, give you y2. If you feed x1 plus x2 in the same time, the output will be equal to y1 plus y2. Okay. Yeah. This idea figure not only used in the real engineering system, but already used in your life. For example, when you okay, if you already takes you think you take a huge effort to solve the problem. Okay, if you think you, if for example, if you take the effort to for example, my exam. Okay, you read a lot, you take the effort that you take is x1. Okay, the grade that you get at the first step maybe get C. Okay, you think that it's not enough for you, you're willing to get more grade or better grade than that, you take the effort double. Okay, you take another one effort, therefore the result should be increasing. Okay, increasing, yes, it can increase, but in the linear, it means if you take the effort double, the grade may be B or maybe A. Okay, something like that. But in the real life, okay, the sometimes the system may be non-linear. If it's non-linear, it means even though you take the effort double, sometimes the final grade may be not increase so much. Okay, or in another case, it may be you take the effort double, but you can get A or maybe get top. Okay, depend on your system. What about the system? The system is yourself. Okay, if your body, if your brain is have a very high efficiency, you take the effort double, you can get A very easily. Okay, but some the brain is maybe not so smart. Okay, you may be in the average level. Okay, therefore when you take the efforts, it will be depend on the system yourself. Okay, you will know yourself. Now in this case, we maybe have the questions why we concentrate on the linear and the time invariant system. There are the several important reasons for analyzing the LTI system are as following here. In general, many real physics systems can be modeled accurately by the linear and the time invariant system, such as the RL, RC, and the RLC in the circuit analysis. Okay? The equations which are modeled from the LTI system for both the continuous time system and the discrete time system are able to solve mathematically. Much information is available for both the analysis and design of the LTI system, and for simplified analysis, we can model and express the mathematically a general input signal xt as the sum of the basic function x1 plus x2 plus x3 plus so on, okay, to xn. Consequently, the system output or the system response yt can be modeled as the sum of the response to each basic functions y1, y2 to yn. Okay. Now, in this class, okay, we will concentrate on the the theory of the the LTI system have the special operator. We call them the convolution. Okay, we call them the convolution, and the convolution. Okay, the convolution concept. Okay, I will introduce the convolution and how to compute the convolution first. Okay, and we will go to the theory to understand them later. Because if I present the theory, I think you don't fully understand them yet until you know how to compute them and the engine of the computation first. Okay, now the idea of the convolution is very is here. Okay. If you have the inputs, okay, if you know the impulse response of the system, output equal to the convolution between the input and the system itself. The system itself. Okay. Now, the way to compute the convolution is here. Y convolve with X convolve with S equal to H convolve with X. Okay. Therefore, it's a cumulative property. Okay. And the equation to compute them is here. Y equal to the integrate minus infinity to infinity d tau, not t, not t. Okay, you convolve in this case, you can see that you convolve in the t domain, in the time domain. But when you integrate, you use tau parameter instead. Okay, you multiply xt with its time shifting version, Okay, and you integrate respect to tau. Okay, I will teach you how to compute this equation first. Okay, the impulse response of the LTI system, HT, is completely mathematically describe the input and the output relationships. Okay, for the LTI system, if you know HT of the system or you know the impulse response of the system, okay, you know everything of them. Okay, and you can find the output very easy. Output equal to the convolution of the input and the system. How to determine the convolution? Okay, I will show you in the detailed step, and it's already show you in the book. Okay, we start by a simple example first. Okay, convolve between xt and ht. Okay, xt is the ut step. Okay, is here. The first step you change every t xt, every t to be tau. Okay, change to be xt to be x tau. Change the axis from t to be tau 2. Okay, change that. Okay, ht is the same manner. ht is the same manner. Okay, change ht to be h tau. H tau. Okay, ht to be h tau and change t to be tau. After that, you maybe pick one of them. Select one cloud. You should select a simple cloud. Okay, a simple cloud to process it. Okay, if you select the difficult cloud, it have a high chance for error. But depend on you. Okay, depend on you. Now in this case, fortunately that both cloud is already identical. Therefore, in this case, you maybe fix xt and process ht. Okay, process ht, you can see that from the equation, tau is ht, t negative, right? Minus tau. How to determine minus tau? H minus tau is mean you determine its time reversal. The time reversal you flip respect to vertical axis. Yeah. Now the signal is already in the suitable form. Is already in the suitable format to process in the next step. Okay. In this case, xt we don't touch them. Xt is always fixed in all time. Okay. But x tau in this case you shift by t. You can see that the red parameter. You shift by 3. Okay. How many times you shifting them? Okay. Depend on the intersection area pattern. Okay. In this case, you can see that if t must be starting from, okay, t starting from infinity to infinity in orange. Okay. The first step, if t starting from infinity in here, the pattern of the intersection is still the same until it reaches to 0. Okay, if it reaches to 0, it means from infinity to 0, we separate from t infinity to 0 to be one section. Okay, the first integration is applied from infinity to 0, as shown in this figure. Okay, do it, see them again. Okay, we starting from infinity. See that during its move, it have no intersection between the red and the pink cloud. Therefore, if it have no intersection, okay, we can count them to be one section clearly. The whole one section from infinity to 0. And when it equal to 0, it have start of the intersection to the pink one. Okay. Now When it's starting to intersect, okay, it move on, okay. Therefore, the integration can separate in two range, okay. The first integration is applied for minus infinity to 0 as shown in the first step, and the second integration is applied from 0 to infinity, okay. After that, we concentrate on each integration pattern, okay. Yeah. The first integration pattern is starting from minus infinity to t is here, okay. You see that this thing is become ht minus tau, ht minus tau. It's already in this form, okay. T in this case is -1, okay. Is we can, okay, when you draw the graph to make you understand, okay, you maybe choose the value between minus infinity to 0, any point between them, okay, but not in the bottom. You maybe your drawing maybe make you misunderstanding, okay. But if you draw like that, it's very clear to understand. You set any value between them, okay, but not in the boundary, okay. Now after you plot them, you can see that xt is the pink graph, okay. ht is this graph, right? You multiply between two graphs first before you integrate them, okay. For time less than 0, the pink equal to 0. 0 multiply anything give you 0, and for time greater than 0, the green equal to 0, okay. 0 multiply anything give you 0 too. Therefore, the whole graph will become 0. The whole graph becomes 0, okay. If it becomes 0, you integrate 0, give you 0, okay. You integrate 0, give you 0. What about this? This thing is the yt output, right? Yt have the value equal to 0 during when t starting from infinity to 0 in our range, okay, in our range. Now you determine the second integrations is applied to this region, okay. The second part of the integration starting from 0 to infinity, okay, to 0 to infinity. In this case, we use 1.5, okay. We use 1.5 to drawing the graph, okay. But in fact, he can be any value between them, okay. Now intersects between the two graph and multiply them first, okay. You multiply between x and s, and this point is t, right? This point is t, okay. Now you can separate the graph in three pieces, okay. For time less than 0, time less than 0, the pink equal to 0. Therefore, 0 multiply anything give you 0, okay, give you 0. And between 0 and this point is t. Between 0 and t, 1 multiply 1 give you 1. And the last part is, okay, for time greater than t, it equal to 0 again, okay. Now, when you integrate this whole graph, okay, the result of xt, ht minus tau, okay, here this graph. You integrate this graph. This graph, when you integrate them, can separate in three pieces, okay, as you show in the picture. Starting from infinity to 0, 0 to t, and t to infinity. Infinity to 0, this so. Okay. 0 to t, 0 to t during this. Okay. And t to infinity. The first part and the last part is the 0. Next step, you integrate 1. In this case, you integrate respect to tau, right? Integrate 1, d tau, give you tau, okay? And you substitute the rank of the integration from 0 to t. Therefore, in this case, yt equal to t. Yt equal to t when you plot them, if t equal to 1, yt equal to 1. T equal to 2, y3 equal to 2. Therefore, the graph will be increasing in the linear form. Or in the graphical point of view, when you integrate the graph, it means you find the area under this graph, okay? The more when the t is moved more, okay? When the tree is increased from 1.5 to 2, 3, 4, 5, the area under this graph will be increasing, okay, in the same manner. In the overall point of view, I will show you how to compute them in each step, okay? The first one, okay, you get xt and ht in the suitable form. You shift ht in the most left hand, okay, in the most left hand to be minus infinity first, okay, and we start to shift them, okay. If we have the intersection, okay, start to intersection or changing the pattern of the intersection, okay, you will separate them into another one integration zone. Okay, now in this case we're starting from 0 to minus infinity to 0. Okay, the result is 0. Okay, and the next one, okay, when the club is increased, okay, you can see that, okay, the intersection area is increased, the area under this club is increased too. Therefore yt is equal to the result of the integration will be increased linearly. Okay, both club is here, yt equal to 0 for time less than 0 and yt equal to t for time greater than 0. Okay, next step, okay, don't forget that in the previous lecture I teach you how to write the mathematics to express the graphic signal. Okay, now the graphic signal is here. We write them to be, merge them to be a single closed form equation, yt equal to t ut. To make you more understand, okay, I will provide you another one example. Okay, if the club is a little bit more complicated, okay, determine the convolution of x t ut minus 2 and ht equal to ut. Okay, this club you can see that is comprised by two unit steps, 1 and 2, and adding them. The way to adding them I already expressed you in the signals. Okay, the way to write the mathematics from the graphical signal. Okay, xt, okay, is a rectangle, okay, change to be x top. Okay, ht change to be s top. Okay, now next step, you can see that in this case the top one is more difficult than the bottom one, the more complex than the bottom one. Therefore we will fix the pink one and we will process, okay, the green one. For the green one we take the time reversal, okay, s minus top. Okay, and after that you try to observe how many intersection pattern that it can be. The first one is the same, we fix the pink one, okay, on the club. Okay, we process the green one. The green one, the first green one is start the area from minus infinity to 0, right? From minus infinity to 0. You can see that the pattern of them is here. From minus infinity to 0. It have no intersection of between the pink and the green yet. Okay. Therefore, minus infinity to 0 is the first integration area. Okay. The next one is moving between 1 and 2. 1 and 2. Okay. And after that, between 2 and infinity. 2 and infinity. Therefore, in this case, we can separate the integration into 3 zones. Okay. Now, the first one very easy. The first integration is applied for time less than 0, as shown in this figure. Okay, time less than 0. Okay, draw two curves, the pink and the green curve, into the same axis. Okay, to multiply them first, xt and ht. Okay, now for time less than 0, the pink equal to 0. Every 0 multiply anything give you 0 all, right? And for time greater than 0, the green equal to 0. Multiply anything, give you 0 again. You integrate 0, give you 0. Okay. Therefore, yt equal to 0 during the time equal to between less than 0. Okay, minus infinity to 0. Yt equal to 0. Now, a little bit more difficult is this part. Okay. The second integration applied between 0 and 2. Okay. Between 0 and 2 is here. You can plot anything, any value between 0 and 2. In this case, we pick, okay, 1.5. Okay, we choose 1.5 to draw them. You maybe choose 1, 1.4, 1.6, depending on you. Okay. Now we move them in here and you multiply them. This point, this location, okay, is T. Remember that is T. Okay, you multiply the green and the or the pink one. Okay, the final result is about here. Okay, as shown in the previous. Okay, and this point equal to T. This point equal to T. Okay, you integrate this graph, and it means you integrate this graph. You integrate from minus infinity to infinity. You can separate them into 3 zones of the integration: minus infinity to 0, minus infinity to 0, 0 to T, 0 to T, and T to infinity. Okay, and when you integrate them, okay, the first part is 0, the last part is the 0, 0 and 0. only the middle part. You integrate one detail. This club is what? One detail give you tau, and you substitute the range from 0 to t. Yeah. Even though the club is similarly to the previous one, but in this case, okay, in the previous one, the club is equal to t reached to infinity, right? But in this case, yt equal to t only between 0 and 2, only 0 and 2. Therefore, the final point of them at 2. At 2, okay, so you substitute them, okay, yt when t equal to 2 is already equal to 2 for this case. The club will be increasing until it's pushed to the maximum point at 2. Okay, why? Okay, if it's greater than 2, the value of them will be depend on the third integration, because the third integration is start from minus from between 2 and plus infinity. Okay, you can pick, okay, when you sketch them, you can choose any one of them. In this case, we choose 2.5, okay, to sketch them. If you choose 2.5, you can sketch the intersections pattern between the pink and the green as shown in the slide. Okay. Now, when you multiply the club, you can see that this point of the green is t point. Okay, but when time greater than 0, when time greater than when time greater than 2, the pink is already equal to 0. 0 multiply anything give you 0. Therefore, the club will become here, and the t is not affect into your final integration. Okay. Now you integrate from infinity to infinity. Okay, d tau. Okay. Yeah. You separate them into 3 zones again, from minus infinity to 0, minus infinity to 0, 0 to 2, 0 to 2, and 2 to infinity. Okay, substitute them. If you here integrate, okay, the first part is a 0, the last part is a 0. Therefore, you integrate tau, d tau, okay, give you tau. Substitute the range between 0 and 2, give you 2. What about the club is? Okay, yt equal to 2 is with it constant and it equal to 2 after that. Okay, in the overall point of view, what happened? I will show you in the slide to connect between this idea. Okay, now the first step, okay, you're moving here from infinity to 0. It have no intersection yet, therefore, the convolution result equation is still 0. Okay, the next one, when you move in the right hand side more, okay, it have a little bit more area than this graph. When you move them more, it have higher of the area than this graph until you move it equal to 2. When it's greater than 2, what happened? It have no more intersection anymore. If it have no more intersection, the area under this graph is already equal to 2 after that. Therefore, in the final step, you know yt for each zone, okay? You must write them into a single equation form that we can write them by use the graphical, okay? Express the graphical by using the mathematical equation. Okay, I think you maybe understand about this idea a little bit one, okay? The next step. Take the exercise here and I will provide you solution. Can you see the exercise number? And during this time, I will grading, okay, checking your attendance. Open the camera to identify yourself. Hello, Jimma.
Hello, sir.
À, ว่าไงธนพัฒน์ไปโรงพยาบาลมาใช่ไหมคราวที่แล้ว
นะครับ
Hi Furkan Good morning
Hello, Ajahn.
ธนพัฒน์เป็นไงบ้างไปพี่ไปโรงพยาบาลป่ะหรือใครคราวที่แล้ว หรืออะไร
พี่
สัก
ชา
อย ย่างฮะ
พี่ชายผมครับ
เหรอไปโดนอะไรมาล่ะอย่าบอกนะโควิดเนี่ย
ไม่ใช่ครับไม่ใช่ครับเล่นบาสครับ แล้วเกิดอุบัติเหตุครับ
เป็นไรเอ็น
เอกเขาทักยิกครับ
โอ้เอ็นกดเท้าพลิกนี่ถึงหนักถึงขั้นต้องไปโรงพยาบาลเลยเหรอปกติฟกช้ำดำเขียว
ผมก็ไม่รู้เห็นพี่บอกเจ็บทั้ง2 ข้างเลยครับ เจ็บแบบ
อ๋อ
ปวดมากๆทนไม่ไหวก็เลยต้องไปโรงพยาบาลนะ
โอเคนะคงหนักจริงๆสิริภพใช่ไหมสิริภพ
ใช่ครับอาจารย์
โอ้ไปยืมที่คาดผมแฟนมาเลยเหรอ
หูฟังเฉยๆครับอาจารย์
เป็นไงอยู่บ้านกันจนหัวฟูหมดเลยดูสาวๆเนี่ยหัวฟูหมดเลยHello Asika right where you came
Bangladesh.
from sir I cannot hear your voice okay
Yeah, Bangladesh.
Bangladesh okay alright and where you are now
In Bangkok.
in Bangkok okay already take the vaccine or not
Not yet.
Not yet. Okay, therefore you must be careful. It spread a lot in the Bangkok. Okay, it's already red zone, right? I heard about that. The same. I live in Suvarnabhumi. Okay, my house is close to the ABAC Suvarnabhumi campus. Okay, the Suvarnabhumi is already red zone too. Okay,
Yeah.
be careful. Okay, remember that you are my student. You cannot die from the COVID. Okay. If you die, you must die with my exam. Okay. You are the engineering cannot die easily. Yeah. Okay, try to take the exercise, okay, and I will provide you solution as your guideline before we leave it, okay, before we close this lecture section, okay, in order to force you, okay, to grab about the idea, to understand about the conceptual idea of the convolution. It's very important, it's a one big problem in the midterm, and we reduce them after that.ปิยนัทใช่ไหมชื่อถูกไหมปิยนัทพิชยุทธใช่ไหม
ครับผมปีชัยยุทธครับ
โอเคเป็นไงได้ไปเที่ยวไหนไหมหัวฟูเชียว
ไม่ได้ไปเที่ยวไหนเลยครับอยู่แต่ห้อง
อยู่ห้องไหนที่บ้านหรือว่าที่หอ
ที่หอครับ
เนี่ยไม่กลับบ้านเหรอหรือว่า
บ้านอยู่ภูเก็ตครับ
โอ้บ้านอยู่ภูเก็ตโอ้โหกลับไปก็วุ่นวายเลยดิก็ต้องมีตรวจอีกรอบหนึ่งใช่ไหม
ใช่ครับก็เลยไม่กลับไปบ้าน
แต่เขากำลังจะให้วัคซีนนี่ได้ไปแล้วยังเนี่ยเห็นภูเก็ตเขาจะขนวัคซีนไปฉีดกันเพื่อจะได้เปิดเมืองค้าขายกันสักที
น่าจะเป็นกลุ่มของโรงแรมครับที่จะได้ก่อนครับ
Okay. I will provide you about the 20 minutes, okay, because the question is a little bit big one, okay, and I will show you a solution, okay. You can see, okay, the detail of the computation again in the book that I provided to you. It's very important, okay. If you don't understand about the convolution well, it's difficult to pass, okay, because this section is a big one, and after that is required this skill, okay. I'm still here. If you have any question, you can ask me.